together, cut it in half, you get that angle. That's the crisscross theorem, folks. Let's try this. Let's give it a shot. Example 1. Find x. Find x. Here's A. We'll put B over here, and then C will be the tough one. All right, let's do a circle. Let's do a crisscross. Whoosh. And whoosh. Oh, by the way, when you do the crisscross theorem, they don't necessarily have to be secants, where they extend on both sides. You can do a crisscross theorem with two chords. Still works. Okay, we're going to call this 88 degrees. We're going to call that 76 degrees. And this is going to be angle X. Okay. Maybe you can set this up yourself. Maybe you can't. Notice how they're two side-to-side arcs. You're not working with the up and down arcs. If you notice, that's an up arc and that's a down arc. We're just working with these two side-to-side arcs, so we're going to be working with this side-to-side angle right here. So that angle is going to be, if you add these two together, cut it in half, and you're going to get that. Let's give this a shot. These are the arcs you're working with, and there's the angle. So if I think I can do this right, I think X is going to be 1/2 of 88 plus 76. Add these two together, divide by 2, or cut it in half, and you get the X. Okay, X equals 1/2 of, what is it, 164? Pretty close to the last problem. We had 160 on the last problem. Half of 164? 82 degrees, folks. That's an 82 degree angle. Some people just remember this. They don't remember this as the crisscross theorem. They just do the average of these two. You know, for example, if you got an 88 on a test and you've got a 76 on the test, what's your average? Well, to find an average, don't you add these two angles together, divide by 2, and you're going to get 82 degrees, or 82%. It's the average. It's the average of these two. Crisscross theorem. Okay, try another one. Was that too easy? Maybe? I don't know. I don't know. I can't look at your faces because you guys are at home and I'm at my home, and you know, I have no idea if you guys are getting this. Let's draw another crisscross. Whoosh. Okay, we got the crisscross, as you can see, two secants crisscrossing in the circle. Let's call this 62 degrees. Let's call this 96 degrees. And of course, I'm talking about these two arc angles. 62, 96. All right, and now what you're probably going to do, Mr. Kosal, you're going to put the X right here, right? No. If I put the X right there, it's pretty much the same as this last problem. It's the same as this problem up here. It's a crisscross theorem. I don't want that. I want the X right there. How do we do this problem? Well, you're really going to do the exact same thing. Do the crisscross theorem. Find this angle right here. Let's call it the red angle, or you can actually label it another variable. Let's call it y. But let's go ahead and do the crisscross theorem to find y, and then use what you know about straight lines. And I think these two angles from here to here make a linear pair. That makes 180 degrees. So subtract your angle y from 180 and you're going to get your x value. All right, I'm talking too much. Find y using the crisscross theorem. I know we're trying to find x, but find y using the crisscross theorem. So y is going to equal 1/2 62 plus 96. Write this down, folks. Try this yourself. So y equals 1/2 of, I think that's 158. Okay, half of 158, half of 175, 75, was it 79? 79? I think it's 79 degrees. 79 degrees. Folks, that is a 79 degree angle. If that's 79, the way that you find x is do 180, because a straight line makes 180. We call these two a linear pair. 180 minus the 79 degrees, that's going to give you 101 degrees. That's your x value, folks. I think you got one or maybe two of these in your homework. tonight. Nothing fancy. Nothing fancy. There's A, there's B. Let's do C. Let's use the back of this. C. B. Criss and cross. 25 degrees. Let's give you the angle measure inside this time. 60 degrees. Let's give you the X for the arc angle. Let's see what you do here. Because the last two problems, I've given you angles on the arc measures, and then I had you find the angle on the inside. This time I'm going to give you the angle on the inside. I want you to find the arc measure. Same thing, folks. This angle on the inside is going to be 1/2 of these two added together. So to set that up, the angle on the inside is going to be 1/2 of those two arcs added together. Add these together, cut it in half, you're going to get that angle measure right there. Okay, just solve for X. You could do this problem two ways. Of course, you can distribute the 1/2, which I'm not going to do because I don't want to work with a 1/2. Or, some of you know this, multiply both sides by 2. And the reason why I'm multiplying by 2 is because 2 times 1/2 cancels. So on the right side, you have just an X plus 25 that comes down. On the left side, multiply 2 by 60, you get 120. And look at this, folks, look at this. No more fractions. Subtract 25 on both sides. And what's your X value? What's that, 95? That has to be 95, folks. Has to be 95. If you take 95 and add it to 125, cut it in half, you're going to get 60 right there. All right, nothing too shabby there. I got another theorem coming for you. Here's your next theorem. Kind of a tough one to wrap your minds around. I'd like you to start off by putting 2 small circles here and then a big circle right over here. So, what are we talking about? Here's your 2 small circles. Here's your big circle. Folks, here's your theorem. And there's no special name for this theorem. It's not, like the crisscross theorem. I don't have a special name. I didn't come up with one. If you want to come up with one and name it yourself, be my guest. But this is the theorem right here, and I have to build up to this theorem to show you what we're doing. I'd like you to put a point on the very bottom of every single one of these circles. And we're going to start over here. I'd like you to make an inscribed angle. So let's go and inscribed angle. Talked about inscribed angles, I believe, in 10.4. You can go back to your notes and take a look at it. But basically, an inscribed angle is always going to be half of its intercepted arc. So for example, if this is, I'm going to pick a random number, 15 degrees. If you can't read that, it says 15. This intercepted arc up here has to be 30. Double it. Alright, moving from this one to this one. I want you to make this angle a little bigger. I want you to open it up. But I'd like you to make this original line that we drew, this one right here, I'd like you to make that the same. So I'm going to try to make that the exact same. I'm trying to build up to this theorem. Okay, but this time I'd like you to increase that angle. I'd like you to take this and swing this open. Kind of like the hinge of a door. You're going to go, and you're going to open this up. So let's open it up to, that looks good. So obviously this angle got larger and the intercepted arc got larger. So there's the intercepted arc now, the arc that's in between the angle. Now let's say this angle right here, this inscribed angle, let's see, it looks like it got bigger to, let's say 40 degrees. I'm picking a random number, folks. If this is 40, that would have to increase to 80. Once again, this looks bigger than your original 30. Now, one more time, folks. Let's make your original line same direction. We're just working on a bigger circle here. Notice how this one's about the same, about the same. about the same. Cool. Now, I would like you to open it up even further. But I'd like you to take this and I'd like you to kind of do... I'd like you to open it up so it's actually a tangent line. So, it kind of looks like it's right here right now, you know, from the last problem, 40 degrees. I'd like you to open, so it looks like a tangent line. Ready? Well, it looks like a tangent line right there. Make a tangent line. What I'm trying to show you here, folks, is that going from the first example to the second example to this theorem, it's all the exact same thing. Let me show you. There's your inscribed angle. There's your intercepted arc. Here's your inscribed angle. There's your intercepted arc. Ready? Here's your inscribed angle. And there's your intercepted arc. It's the exact same thing. The only difference from here to here is that your angle actually went outside of the circle. I mean, this is inside the circle, but then it goes, this is outside the circle right here. It's still the same thing. That is what we call an inscribed angle. It's an angle where the vertex is on the circle. That's an angle where the vertex is on the circle, vertex is on the circle. Inscribed angle, inscribed angle, inscribed angle. Let's say this opened up to, I don't know, 75 degrees. If that inscribed angle right there, the yellow angle is 75 degrees, then this intercepted arc has to be 150. Folks, here's your theorem. It just looks a little different from these first two, but they're all inscribed angles. They're all inscribed angles. Smiley face. I don't know. All right, EX2.